Why is there something rather than nothing? What is dark matter and dark energy? Is the universe infinite? These are some of the biggest questions in cosmology today, and scientists are working hard to give us answers. In the past decade, an extraordinary claim has captivated astrophysicists that the expanding universe we see around us is not the only one, that billions of other universes are out there. There is not one universe, but rather there is a multiverse.
We have some rather interesting ideas, and they're all traceable to the concept of the multiverse, where we, in our friendly universe with known laws of physics, are just one bubble of many bubbles that would come in and out of existence in this sort of meta system of multiverses. And if that's the case, then we can definitely point to a beginning of our universe because there's some other structure that's there pumping them out and pulling them back. But that just simply shifts the question to how did the multiverse get here? Unless the multiverse was always there. And I know that's philosophically unpleasant, but if you're exploring open-minded to what is possible in the universe, quantum mechanics looked really weird to us in the 1900s. Just because it looks weird doesn't mean it can't be true.
In the early 1990s, there was a big unknown about the expansion of the universe. It might either have enough energy density to stop its expansion and recollapse, or it might have so little energy density that it would never stop expanding. But one thing was known for certain: gravity would slow the expansion as time went on. Granted, the slowing has not been observed, but theoretically, the universe has to slow down its expansion. The universe is full of matter, and the attractive force of gravity pulls all matter together. Then came 1998 and the Hubble telescope observations of very distant supernovae that showed that a long time ago, the universe was actually expanding more slowly than it is today. So the expansion of the universe has not been slowing due to gravity, as everyone thought, it has been accelerating. No one expected this, and no one could provide an explanation for it. Eventually, theorists came up with all sorts of explanations, but to this day, scientists don't know what the correct explanation is, but they have given the solution a name. It is called dark energy. Another big one is dark matter, which is a hypothetical form of matter that comprises about 85% of the matter in the universe. The primary evidence for dark matter comes from calculations showing that many galaxies would fly apart, and they would not have formed, or that they would not move as they do if they did not contain a large amount of unseen matter. Other lines of evidence include observations in gravitational lensing and the cosmic microwave background, along with astronomical observations of the observable universe's current structure and the formation and evolution of galaxies. Another unsolved mystery in cosmology, responsible for everything that we ever care about, is the matter-antimatter asymmetry problem.
In 14 billion years ago, or if you want to be 3 decimals precise, 13.7 billion years ago, the universe was much smaller, much denser, much hotter. So hot that matter and energy formed this soup of interplay. Right now, you take it for granted that we sit here and you're not going to pop into a ball of energy and dissipate into space. We kind of expect that that is not going to happen quite that way to you. And so why? Because we don't live in an environment for which that's an everyday occurrence. But there are environments in the universe where that happens all the time. Like, for example, the center of a star, at the origins of the universe. In fact, if we were immersed in those environments and did not otherwise vaporize, it would be a very natural thing to watch particles pop into existence out of nothing, but it's actually energy, and watch particles come back together and make energy again. That's a very natural thing. Exotic to us, requiring an Einstein to have figured out. But under some conditions, it's just every day. So you go back in time and you say, here is this ball of energy. And as the universe cools, the energy spontaneously becomes matter. Now, if you're hot enough, that is a two-way street. Matter becomes energy, energy becomes matter. But as the universe expands and cools, you reach a point where the pool of energy is no longer high enough to make particles. Well, if that's the case, all matter and antimatter would come back together, annihilate, make a beam of light, and all we have in the entire universe are beams of light. But that's not the universe we live in. The universe we live in has an imbalance of matter and antimatter. In fact, for every 100 million matter-antimatter particle pairs, there was one surplus matter particle without a counterpart. And it's a big, mysterious asymmetry. We don't know what caused that asymmetry. We have some ideas, but we don't know for sure. But there's that asymmetry, and all stars, galaxies, planets, gas clouds, light, everything you've ever thought of as a thing is made out of that 1 in 100 million particles that did not annihilate. And everything else is just light. And that light we see, in part, as the cosmic microwave background in the universe.
Why is there something rather than nothing? Is a question about the reason for basic existence, which has been raised for millennia by ancient philosophers. Greek philosopher Aristotle argued that everything in the universe must have a cause, culminating in the ultimate uncaused cause. Physicists such as Stephen Hawking and Lawrence Krauss have offered explanations that rely on quantum mechanics, saying that in a quantum vacuum state, virtual particles and space-time bubbles will spontaneously come into existence, which is also mathematically proven by physicists. In an inflationary vacuum with a mass equivalent to a bag of sugar, the laws of physics permit such matter to pop into existence from nothing. Of course, the next obvious question is, where did the laws of physics come from? But even things we do have an answer for, in a cosmic perspective, seem so arcane. For example, the vast space in the universe.
Because light does not travel at an infinitely fast speed. It travels 186,000 miles per second. That's fast, but it's not infinite. It's so not infinite that you would be frustrated having a phone conversation with someone on the moon because the delay is 3 seconds. You would speak, and by the time they heard you reply to them, 3 seconds would have passed. It would not make a good phone conversation. That's how long it takes the light just to get to the moon. It takes 8 minutes, 20 seconds to get to the sun. It takes 100,000 years to cross the galaxy. It takes 1 billion years to get to the distant galaxies. 13.7 billion years to cross the known universe. It takes time. Put a pin in that fact. Another fact. The universe had a birthday 13.7 billion years ago. So imagine a universe that is infinitely large. Now, put yourself in the middle, and I tell you, this universe was born 13.7 billion years ago. So, let's go out to the circle, to the sphere around us, go to the spot that's 13.7 billion light years away. In other words, go to the spot where light from objects has taken 13.7 billion years to reach you. You're going to be watching that object being born because its birth light is just now reaching you. Come in a little bit. You're going to see those in their toddler years. Come in a little, they're in the adolescence. Come in a little closer. Come to the present day and you see everyone in their modern day maturity. So there's a limit to how far you can see in an infinite universe if the universe had a birth date and the speed of light is finite. Wait 1 billion years. Now the horizon is 14.7 billion light years away. Now you're seeing those galaxies get born. So the interesting thing about the universe in which we live, as long as there's galaxies that get overtaken by this expanding horizon, you will always bear witness to the birth of the universe because somebody is always being born. The interesting part is if the signature of the Big Bang goes away, that would tell you that your horizon washed over a region of the universe where there are no more galaxies to show you their birthday clothes. That would tell you that you in fact reached the edge of the universe.
We may never get answers that satisfy our curiosity about the biggest questions in cosmology, but that doesn't mean we shouldn't explore the unknown and try to resolve age-old questions like, was there a time before everything came into existence? Or in more modern terms, what was there before the Big Bang?
I am undaunted by the limitations of words we use. Just because we date the beginning of time at the Big Bang does not prevent me from thinking about before, even in the absence of data. I'm open to what could possibly be going on before the Big Bang, number one. Number two, right now we have no clue how to look there. We just Don't. Do I think there's a forever barrier? That simply wouldn't be wise, given the history of science, about which I do a fair amount of study. I take my cues from great thinkers of the past, some of whom believed they had hit a boundary, believed the end was right there in front of them. And then sure enough, a cleverer person than they comes along and says, there's a problem I'm solving. It's a lesson in the belief that you happen to be alive at a time where we've reached the end of knowledge. That itself is hubris. That itself has the implicit assumption that you are smart enough to know that we've reached the end of knowledge. Admit the possibility that someone could be born after you who's cleverer than you, cleverer than me, who will solve all the problems all the time.
Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.